Would you have a look at that handsome guy that you're looking at right here on your screen? That is a picture of me. It is an NFT on the Sui blockchain. And I'm going to do this sort of unscripted introduction and explain a little bit why NFTs on Sui are different from NFTs on different blockchains and why Sui offers some exciting alternatives to how state is approached versus an EVM. So, without getting too technical, I'll try to explain this from a somewhat technical perspective, and then I'll do a tutorial to demonstrate all of this. But I want to explain things from a high level concept. This is an NFT, and this image of me exists entirely on the Sui blockchain. It isn't some pointer to an IPFS hash, as is usually the case on EVM. This image is what is called an object on the Sui blockchain. It has a corresponding Walrus protocol object ID. Walrus protocol is this thing that is entirely native to Sui that is analogous to IPFS. And it's just really cool. You can't really do this with a typical EVM. So that is very cool. And I started messing with Sui recently and got introduced to these objects that exist in a Move smart contract. And it really reminded me of this ERC6551 EIP that I've become a huge fan of. ERC6551, if you want to check it out, it's under review as an EIP right now. What it does is it introduces this concept of token bound accounts. So on a typical EVM, you have natively two different types of accounts. You have your externally owned accounts, EOAs, which are, your key pair essentially. The keys derived from your mnemonic. It's what you use when you want to sign transactions. So your public key is, your address, and then you've got your private key that you use to sign transactions, which is derived from your mnemonic. That's your EOA. And then there are these contract accounts. Contract accounts you can think of as just the address of a smart contract where you can send funds to, or you can reference state from that contract. It has an address. What ERC6551 does is it introduces this concept of token bound accounts. And basically, in the simplest terms of what that does is you can have an NFT which it itself has this 6551 account associated with it. So you can think, my NFT, my monkey NFT is so great because my monkey NFT holds 3 monkey NFTs and it's got, a boatload of Ethereum that it holds. My monkey NFT is rich. It's balling out of control. That's kind of like the TLDR on 6551. I've used it to build some pretty cool things. Maybe I'll demonstrate those in some future videos. But looking at Sui, Sui has accounts, very similar to the EOAs. It has packages, which are analogous to smart contracts. Packages can have these modules within them. But Sui has this thing that Ethereum doesn't have native, or the EVM doesn't have native, and it's these objects. And that's going to be something that I maybe try to really focus on in this tutorial. These objects are things that have unique identifiers on the Sui blockchain. They have their own address by which they can be referenced, and they're just a completely unique thing to Sui. So as we revisit this NFT here, we're going to notice a lot of cool things, like just by built in, I can use this NFT as a wallet. I can send it Sui tokens. I can send it other NFTs, and I can build a lot of cool other things. So hopefully that will start to kind of sink in a little bit. Sui has been exploding at the time of recording in this in value, the token. And I've just noticed not a lot of people are familiar with it. So I think it's cool and it's exciting. I think the Walrus protocol is particularly incredible. So hopefully this will be an introduction to Sui for some people. We are so back. So after a little downtime with the Walrus publisher, it's been a few days. I've gotten a haircut in the meantime, but we've got the publisher working again, so we can finally proceed with this tutorial a couple days later. The first thing you're going to want to do is you're going to want to go to this URL, publish.walrus.site. And what we're going to be doing here is similar to pinning a file. We're going to be pinning an image. It's just called uploading to Walrus. So let's go ahead and do that. This is a UI that makes it really simple. You can also do this through an API if you prefer. I'm just going to demo the easy way. And let's add another picture of myself. Hopefully people aren't going to think I'm narcissistic, but I just don't have a lot of pictures on this computer. So it's as simple as that. A few other things I should go over. Epochs. Currently, one epoch is approximately 1 day. So however many days however many epochs you choose, that's how long that blob, that object, is going to remain live within Walrus. So you can fiddle around with that. If you choose 1 epoch, for example, after a day, that blob will no longer be available in Walrus. So just be cognizant of that. I'm going to click upload, and then I am going to note a few things that I get. Here we go. Great. So I've got my blob ID and I've got my object, and look at that, stored until 33. So just take note of those and we will be proceeding from here. Now that we've got our object ID and our blob ID, we're gonna go ahead and move over to VS Code and get ready to set up this NFT project. Just so I have that information available to me, I've gone ahead and just created a text file where I save my object ID and my blob ID. We'll go from there. We are going to assume that you already have Sui installed on your machine, all the binaries and everything necessary tooling for building these move-based projects. And the first thing we are going to go ahead and do is instantiate a new move project. And we're going to do that with Sui move new NFT creator. This is going to go ahead and give us an entire new move package where we're going to have a template. These are .move files. This would be analogous to like a .sol file if you're coming from an EVM sort of environment. We've got some sort of like test templates, and then if you're familiar with Rust, these .toml files, similar to like a cargo.toml file, will be present here. We're first going to go ahead and dive right into building out our smart contract, which is, it's really, think of it as a package, and we're going to sort of instantiate it as a module, like module NFT creator, simple NFT. And we can think of this similar to instantiating a contract if we were developing a Solidity smart contract. But I'm sure that no one really wants to sit here and watch me type a bunch of things out. So I'm going to paste some things in here and we'll go from there. Okay, so everything we have here, this section sets up the module and all of the imports that are necessary dependencies and such. Each of these imports serves a specific purpose, everything from handling transactions to managing object IDs. If we look at this, for example, what we're doing, or what this does, is specifically for transaction context and sender info. We'll elaborate on this a little bit more. This is for creating unique object IDs. Remember, objects are these new things in Sui, which we'll become more familiar with as we build this. This is for transferring objects between addresses. This right here is for package publishing. For when we We publish this guy. This is for NFT metadata display, similar to how we may display things or display IPFS content. But remember, this is all going to exist entirely on Sui within the Walrus protocol. Once we get to the end product, it'll be pretty cool. This is going to be for handling Sui token balances. Our NFT at the end of this is actually going to be holding Sui tokens, which is really cool, I think. This is for the Sui token type, which we'll explain a little bit more when we get there and actually do the transfer. This is for cryptocurrency operations. Again, once we get a little farther along, that'll become more clear. And then this is for string operations, as you'd expect, any sort of text. So I'll go ahead, and the next thing we're going to do is create a struct. Structs are going to be very familiar for anyone coming from an EVM environment. We'll call it simple NFT. We'll say has key store. Let me go ahead and paste this in here, and then we will elaborate on this a little bit more. Okay, so we have our full struct definition here, and let's elaborate on this a little bit more. As I mentioned, a simple NFT has a key store, and what this keyword does is it makes this simple NFT as we instantiate it into an actual Sui object, such that it can be stored in global storage on the Sui DLT. Store keyword allows it to be transferred between addresses. The fields define what data the NFTs hold. These are the fields. Like if you're coming from an EVM background, I don't think I really need to explain all of this. The ID is going to be some unique identifier of the NFT. Then we've got the NFT's name, its description here. We've got that blob ID that we stashed away. We've got the Walrus object reference, which we're going to be using. And then we have the balance. How much Sui does our NFT actually hold? So the next thing we're going to do is some sort of like security initialization stuff. So we'll do struct simple NFT has drop. This is for witness type for one-time initialization. And then we'll have some error constants, which I'll just go ahead and paste in here. Those aren't going to be too exciting. The next thing we're going to talk about is a special kind of function, which is the init function, which you can see here on your screen. The init function is a special function that is called when this entire package gets deployed to the Sui blockchain. It's only called first time upon deployment, and we'll kind of go over what this does. This first part here creates templates for how the NFT will be displayed. All of that stuff will be filled in when we actually mint new NFTs. But it's just sort of putting out these placeholders that will automatically be filled with each NFT instance. And it sets up how NFTs will be displayed by this entire package. The publisher capability is the next thing. And this is a cool thing that I want to describe a little bit. This is like a proof that the official publisher of these NFTs put that out. And the witness parameter of the type simple NFT is this one-time use type that proves that we're the original deployer. It's a unique security feature of Sui, and only the original deployer can claim this capability at initialization. So then we have this create display configuration stuff, and that creates the display and configuration that tells Sui how to present the NFT in wallets and explorers, anything that might be externally reading that information to display it. The simple NFT parameter tells Sui that this display config is specifically for our NFT type. And the update version call is necessary to make these settings take effect. And then we have the transfer objects to the deployer part. At the end, we transfer both the publisher capability and the display configuration to the deployer address. And this is important because the publisher capability might be needed for future updates, and the display configuration needs to exist somewhere on chain, so it has that immutability. And the deployer should maintain control over these administrative objects upon deployment. So I'll describe this as a real world analogy, like we're creating some sort of new trading card, like a Pokemon card, something like that. The templates are like the card layout and the design. The publisher capability is like the official trademark or copyright of the brand. The display configuration is like the official style guide for the card, how it's going to look. And then transferring to the deployer is like keeping that trademark certificate that writes in a vault after putting everything out. The very cool thing about this is the publisher capability is itself an object on the Sui chain, and that can be transferred to other addresses, which would then give other people the rights for that publishing capability. So it's not like in an EVM where you might just have an array of addresses where you can add a new admin or transfer an admin. This thing is an object with a unique address that you can transfer to someone else's wallet, and it itself sort of becomes this ownable asset, which is another very cool feature of all of this. So now we have our mint NFT function, and before we proceed with this, I'm going to backtrack a little bit and just remind you of some of these error messages that we had that I glossed over earlier. These are just some error messages related to if we do not pass any attributes in the necessary places. So no name or no blob ID. These are the error codes associated with that. As we go back to this function, we have some keywords. We have public, which just means anyone can call the function. This might not be the case for how most NFTs are set up, but the way this contract is going to work, that anyone that calls that function gets sent the NFT to them. Entry just means that it can be called directly within a transaction. It's going to be modifying something with the blockchain, something with the state. Fun is not because it's so much fun, that's just the keyword for defining a function, declaring a function. And then obviously we have the name mint NFT and the parameters. Some of these parameters are pretty obvious. The name is a string, description is a string, all of these other things are strings, but this context, transaction context, maybe we should focus on it a little bit. This means it is a mutable reference, which is similar to Rust, which might not be entirely familiar to a lot of people in Solidity world. It's something new. If you're familiar with Golang, it'll be familiar. This just means that it's a reference, it's a pointer to the data. Mut, mute, however you want to say it, indicates that the reference allows modifying of the original data. Transaction context contains the transaction information, like who's sending the transaction, the current epoch, fresh object IDs, gas information, etc. Lots of stuff corresponding to the transaction that's going to happen. And then these are the input validation parts here. Assert is very similar to require in Solidity. We just have checks to make sure that it's not an empty name. And then we also make sure that it's not an empty blob ID. So moving on to the NFT creation here. This part is pretty straightforward. We're just instantiating a simple NFT. We're giving it all of the parameters necessary for that NFT struct that we defined further up in the code, and we are initializing it with a balance of 0. So that's pretty simple there. And then finally at the end, we are transferring it to the person who calls the function. So it gets the transaction sender's address via here, and it moves the NFT to that address with this transfer function. After the transfer, the NFT exists on chain at the receiver's address. So a couple of key points just to harp on. If we move back up here, entry means that this can be called directly in transactions. We have the information related to the mutable attribute of this transaction context and that it's pointer to a reference. So we need those because we need to generate new object IDs, we need to access sender information, and we need to modify the blockchain state. In all, this function validates the inputs, and that's done here. It creates the NFT object here, and it sets up the display / metadata, transfers it to the caller, and initializes the NFT with 0 balance. Next, we're going to go over our add balance and withdraw balance functions. This is for adding balance and withdrawing from the NFT itself, so we can send Sui tokens to our NFT. And there are some concepts that we'll focus on, so I've gone ahead and really commented these up in advance if you're following along and just want to read along with the comments here. What we have is obviously all of the parameters to the function. We've got a mutable reference to the NFT that we're adding the balance to. We've got a mutable reference to this Sui coin object. This coin of Sui is the generic type for a Sui coin object. And we're going to focus in on how this balance dot split, that's kind of how I think of it, how this function works to break off or to split off little pieces of that entire coin object. The key points of this overall add balance function are that it takes a Sui coin object and adds some of it to the NFT. We mentioned that that coin.sui is a generic type, and we have the split and join functions, which I made a little graphic right here, a file that demonstrates how this works. So let's say we have the original coin, it's 1 Sui in this add balance example. If we call split of 0.1, we're splitting off 0.1, and then we can join it with the balance of the NFT. And now that NFT has 0.1 Sui. And the withdraw balance kind of works the other way. We have the NFT's balance. We're going to split 0.1 from that, and a new coin is created. It contains 0.1 Sui, and that gets transferred to the caller with our withdraw balance function. So let's move back over to our function. And that's basically just explaining how this entire process here is working. We get a mutable reference to the coin's balance. We split off the specified amount of that payment coin, and then we join that split amount into the NFT's balance, and we do the exact opposite with the withdraw balance function. We split the specified amount from the NFT's balance. We create this new generic coin object, and then we transfer the new coin to whoever's calling that function, the transaction sender. And it's a little bit of a unique approach to how this works versus sending things directly with EVM using some of these built-in split and join functions. But once you get the hang of it, it's really easy to use and isn't too complicated at all. It's a modality that I'm seeing done with a lot of these Sui contracts, packages, whatever you want to call them. And great, finally, that just brings us to our view functions down here, which I don't think need a whole ton of elaboration. These are just public functions. Notice they're not entry functions. We're not updating any state of the blockchain. And they're basically just all getters. Get name, get description, get Walrus blob ID, and get Walrus Sui object. We can see we're passing these references. And if you're coming from an EVM environment, this should be pretty self-explanatory. So at this point, we're ready to go ahead and build our package. Actually, one more thing I should mention. We do need to update our .toml file, .toml, and this will be on GitHub, so if you just want to grab this or pause and copy if you're coding along, we need to update this configuration file and save it. So we are going to move into our NFT creator directory, and then we're just going to do Sui move build. And we are now building, we have just successfully built our package. So we're going to get our auto-generated move.lock file, and from here we are just going to go ahead and deploy the contract. We are going to publish or deploy this with Sui client publish. We're going to set our gas budget to this amount of mist is the small denomination of Sui tokens. And we're going to get a lot of information from this, which we can go through here shortly. The most important thing is our package ID right here. This is sort of like our contract address, which we can plug into SuiScan and see that. Okay, so we are almost there. We're just going to need a couple of things from SuiScan. We're going to grab this object's ID, which we can grab from right here. That's our NFT's object ID. We're going to need that for what we're going to call. Let me switch back into VS Code here. So I'll have this placeholder also for you. We can throw our NFT's object ID right there. And then we're going to need to do something a little bit different for getting this, kind of going back to the Sui object, the how should I say, the coin object, where we have to do the split and the breaking of those coins and everything. So we're gonna do Sui client gas. And what that's going to do is that's going to give us all of the token objects that we've set up. You'll likely just probably have one line that has whatever you've used to hit the faucet, but I've done this several times. And for this instantiation, I'm just going to send 0.1. I won't send a full one. But we need to grab one of these token object IDs so we can pass that along in the function call when we're going to be calling that add balance using this command line prompt. So I'm going to grab that object ID and let's put that here. And then finally I can grab the package ID, which again, if you want to be reminded of that, after deployment, we should have our package ID right here. So there's our package ID. Maybe I even grabbed that wrong. So let's put in the correct package ID here. Paste that there. That's right. It's right there. Hopefully I didn't mess something up. So let's copy this. And I'm going to paste it into my terminal. Call the function. While that is running, Sui is really fast, so by the time I switch back over here, we should be good to go. So let me refresh on here, and we should have a balance. Oh, of course, I've got to verify that I'm human. And boom, there we go. Our NFT has a balance now, and you can send this however much you want to send, as long as you set that parameter in that command line prompt. And just to be clear, let me switch back over to presentation. If you want to have a more elaborate description, that's as simple as changing these parameters when we're calling the mint NFT function. If you want to send it more, we would just pass a different parameter to this. But at this point, congratulations, you have minted an NFT, you've deployed an NFT smart contract on Sui, and you've done something that isn't possible on the EVM. You've sent that NFT some native token, which otherwise you would need to deploy 3 ERC6551 contracts, some registry contract to get the token bound account. It would be complicated, complex. This is one simple package, a few functions, a few read functions, and we are good to go. So great job. I probably will put out some more content in this vein going forward. But yeah, thanks for watching. Stay tuned.